today, I'll give you a lesson on acceleration. And I think the first thing that we need, of course, we know from our position time graphs that acceleration change in velocity. So the next thing that happens is our formula. So if change in velocity is going to be symbolized by a symbol called delta. A delta means to change in. So whatever we put that in front of, that's what we're changing. So in this case, we're going to have a change in velocity. So acceleration is equal to a change in velocity over time. What that does is that makes acceleration a rate. It is a rate of change that occurs. And one of the most important things you need to remember is acceleration is not velocity. They are not the same thing. Acceleration is how velocity changes. So while they have a relationship, they are not the same thing. So please don't put those two things in the same category. Alright, back to the formula. If I have a change in, that also means this, that it's final minus initial. So I have a final velocity, I have an initial velocity, I subtract those two, divide it by the time, and that will give me my acceleration. My units for acceleration, most of the time our standard unit is meters per second, second times second. That means every second your velocity is changing. But we're going to write it this way. It's going to look like this, meters per second squared. So when you see meters per second squared, that is our change in velocity or our acceleration. So let's look at a problem and see how we work that. A car starts from rest and accelerates to 20 meters per second in 15 seconds. What is the rate of acceleration? Well, if we look at what's given, so we're going to write our givens. I have 20 meters per second. That is a velocity of 20 meters per second. And I have a time. That's 15 seconds. But I know by formula I need a final minus initial velocity over time. So which is this? Is this my final or my initial? Well, go back to the problem. It says it starts from rest. So that's going to be my initial. It starts from rest, so that's 0 meters per second, and that's going to make that my final velocity. So now what I'm going to have is I'm just going to fill in the formula. Acceleration is equal to final velocity 20 minus my initial 0 divided by the time. So my acceleration is 20 divided by 15, which is 1.33 meters per second squared. That'll give me my acceleration rate for this problem. Now I want you to notice that when we do math problems, we put our givens, we show our formula, we put our work, and we give our answer. In this format, this is the way I want all of your math problems to look. Let's do another one. How do I find acceleration when I'm using displacement? Well, if I'm using displacement, I have a different formula. I have final velocity squared is equal to initial velocity squared plus 2 times the acceleration, there's that delta again, times my change in x. Now we learned in class the other day that change in x is my displacement. Change in x is going to be my displacement. So I'm going to use this formula when I'm trying to find acceleration or I'm trying to find velocity when I have displacement. Notice what we don't have. We do not have, in this formula, we do not have time. Time is not included in the formula. So what does a problem like this look like? An object starts from rest and accelerates a distance of 50 meters. So I have a change in x of 50 meters, and it accelerates at a rate of 2.4 meters per second squared. So I have an acceleration of 2.4 meters per second squared. I know this is acceleration because it has the square on it. What is the final velocity? So I'm looking for final velocity. And notice here it also says it starts from rest, so that's my initial velocity. So that's going to be 0 meters per second. So my formula is final velocity squared is equal to initial velocity squared plus 2 times acceleration times my displacement. So final velocity squared is equal to 0 plus 2 times my acceleration, which is 2.4, times my displacement, which is 50. So Vf squared is going to be equal to 240. There's the square. So now I need to get rid of the square. So I'm going to square root both sides. And that's going to give me final velocity equal to 15.49 meters per second. We're rounding off to 2 decimal places whenever possible. So once again, this is how a problem looks. This is the format in which it needs to be done. And this is how to use that problem with that formula. Well, the next component is finding acceleration with displacement, and this time we include time. So if I have time, look at the formula that I have. I have my x, which is once again my displacement. I have initial velocity times time plus 1/2 acceleration times time squared. This one includes, but what do I not have in this formula? Well, in this formula, I do not have final velocity. That will not be included in this formula. So see, what we have is we have different formulas that give us ways of finding things with what's given to us. That's why it's important we put the givens. So a car has an initial velocity of 10 meters per second. So there's an initial velocity of 10 meters per second. And it accelerates for 10 seconds at a rate of 1.2 meters per second squared. So I accelerated at a rate of 10 seconds, so that's a time of 10 seconds. And I do this at a rate of 1.2 meters per second squared. So my acceleration is 1.2 meters per second squared. So what am I going to do with this? What am I trying to find? How far did it travel during this time? So once again, I'm trying to find x because we're on the horizontal surface. So once again, what is my formula? Well, I'm going to use this formula here. X is equal to initial velocity times time plus 1/2 acceleration times time squared. So x, which is what I'm trying to find, I have an initial velocity times time plus 1/2 my acceleration, 1.2, times time squared, which is 10 squared. So x is equal to 10 times 10 is 100 plus 1/2 times 1.2 times 10 squared is 60. So my displacement, or the distance that this traveled, is 160 meters. So this will give you some example, some way of knowing how far this goes. And this also tells us how to use the formulas that we have with acceleration. We have that formula, x is equal to vi times time plus 1/2 at squared. I have this one, vf squared is equal to vi squared plus 2a times my displacement. And then of course I have my original formula, which is acceleration is equal to my change in velocity divided by time.